This is Akashvani.
Radioscope, the National Science Magazine program.
Good evening, dear listeners. Very warm welcome to the September edition of National Science Magazine, Radioscope. Science is not just a subject. It is a way of thinking, a methodology to unveil the mysteries of the universe. It is the language in which nature speaks to us. Scientists act as translators who bring us closer to nature's profound secrets. Throughout this September edition of Radioscope, we'll delve into fascinating scientific breakthroughs, meet renowned scientists, and explore how science has transformed the world in ways we could have never imagined. So, sit back, relax, and let us take you on a thrilling journey through the captivating realm of science.
Today, we have a fascinating journey spanning across space science to medical and technological advancements. Astrophysics, the science of the stars, takes us beyond the confines of our planet, igniting our imagination and propelling us to venture into the unknown. Firstly, let's learn how Dr. Aswin Sekhar, India's first professional meteor scientist, became captivated by the mysteries of the cosmos, the path that led to his distinguished career, and how a minor planet was named after him.
Isn't it fascinating to accept the reality that a planet is named after someone among us? Definitely, yes. But he stands out from us for his excellence in academics and career. A solar system dynamicist and astronomer by profession at the Paris Observatory, he is someone who has keen interest in areas like celestial mechanics and orbital dynamics. He is also the member of the Royal Astronomical Society and works as an astrophysicist at the Institute of Celestial Mechanics. Recently, a minor planet was named after him. So let's welcome Aswin Sekhar.
Thank you.
You have a long list of academic qualifications if someone checks your profile. So what's your current area of expertise and can you explain that?
My present line of work is orbital dynamics. It's essentially to do with studying the trajectories and orbits of small bodies in the solar system like asteroids, comets, meteors, and so on.
Can you elaborate on some of the recent discoveries that might spark the interest of the common people? Because your name was given to a minor planet and suddenly, all these social media posts were triggered with all these interest in space.
Well, I think the latest sort of exciting mission which happened recently is something called a DART mission done by NASA. It's actually a mission designed to understand how to avoid asteroid threats on Earth. So it's essentially trying to send a spacecraft, have an impact with an asteroid, try to change its trajectory a wee bit in such a way that it's going to miss our Earth and make our Earth safer. So this is one of the latest, most exciting astrophysics missions in my field of study. And this is something designed to make our Earth safer in future. Because about 66 million years ago, it's important to remember that a whole species like dinosaurs was wiped out by asteroid hit. So these threats are real. Although some of these giant hits are rare, these threats are still real, and it's very important for us to prepare and understand how to deal with some of these threats.
Minor planet was named after you. So what exactly is a minor planet? Then there's a planet also.
In general, a minor planet or an asteroid is simply a rock which revolves around the sun. So in general, these bodies come in all sizes and shapes, and a large chunk of these bodies, they are actually between the orbits of Mars and Jupiter. So minor planets are also called asteroids, and this is the biggest small body population in our solar system, apart from other small bodies like comets and meteoroid particles and so on.
Can you tell us more about that minor planet to which your name was given? And also there were 3 other people who had this wonderful opportunity. Can you elaborate on that?
Only things I know about this minor planet, it's about 4 kilometers in diameter. And it's about 4 astronomical units away from the sun, which means 4 times that of the distance between the sun and the Earth, which approximately comes about 600 million kilometers or so on. The orbital period of this minor planet, it takes about 4 years to go around the sun. And I have never seen an image of this minor planet. I understand that people haven't had any follow-up observations on this. Just for a fun, I thought I would ask some of my observational astronomer colleagues in India and abroad just to point the telescope at this object and give me a nice picture at some point. I'm not an expert in observational astronomy, so I would give that work to some of my well-wisher colleagues, and hopefully they will give me a nice picture. This minor planet was discovered in year 2000. It was observed by some astronomers at this Lowell Observatory, and which was assigned my name by the International Astronomical Union. The other scientists who were given the same honor this particular year in the same list were Ashok Verma, Ritu Parekh, and Kumar Venkatramani. And I understand that these three scientists, they all work for NASA. So interestingly, I am probably the only non-NASA scientist to win this honor in this list from India.
As an astronomer, what exactly do you mean by stargazing?
Well, I think the present astrophysics community is super specialized. So if you ask a stellar physicist, he would say that it depends on what kind of stars you have to look at.
Okay.
So there are people who work in different wavelengths in astronomy. So today there are people who look at stars in different parts of the spectrum. So like the ultraviolet, infrared, optical, microwave, radio, and so on. So astronomers look at objects not just which are sparkling and fun to look at, but also objects which are very difficult to track, very faint objects which are very exciting in terms of pure science point of view and so on. So it's a collection of lots of different bodies in the universe which are observed constantly in different wavelengths of light so that we understand our universe better.
So what's the process of naming these planets?
So there are two ways of naming it. So one is a ceremonial way of doing it. So whichever person who discovers an asteroid or a minor planet, they get the naming rights to suggest someone on whom the minor planet could be named. So this is one of the ways why there are a lot of these fans and admirers of different people they gift the asteroid name to some of their idols. So people like Vishy Anand, Pandit Jasraj, Tagore, Gandhiji, some of these asteroid names are like that because there are some Indians who really wanted to give a tribute to them. They named it after them. In my case, it's different. It's more like a scientific nomination. So there were some legends in my own field who nominated my name, citing my body of work in meteor science. And it goes through the International Astronomical Union Nomenclature Committee. They assess this work and look at my track record and they approve the name. And that's how they announce this new minor planet in my name. So it's essentially like a recognition for my body of work in meteor science. And I'm deeply humbled and honored by this recognition from the scientific community.
When you observe an object or a group of objects, what are the challenges that you face?
So the main thing is you have to be lucky that whenever you book for telescope time, you have to hope and pray that the weather is good. Sky willingly, you'll be able to observe the areas of sky which you really want to observe. That's one challenge. The next challenge is to reach to some of these observatories. As you can imagine, presently in most parts of the world, it's heavily light polluted. So you have to find areas which have exceptionally good clear skies, pristine skies as it were, to make some of these telescopes and pitch in some of these telescopes. So whether you're an amateur astronomer or a professional astronomer, what you need is a dark spot where you have very little light pollution, where the weather is conducive for you, and then you will be able to look at these objects in the sky. The other thing is to go to some of these observatories, which are also in remote parts of the world. So there are some of these biggest observatories in rural parts of South Africa, Chile, Hawaii, Australia, and Canary Islands in Spain, and so on. So the challenge is to book for telescope time, find a good window of opportunity to observe the object in the sky, and then reach there, get the observation, download the data, bring that back to your institute, and then process the data for years and years.
If someone started out as a stargazer and if they want to explore more like you, what would be your advice to them?
Well, my first advice is if you're really driven by pure science, go for an undergrad in a basic science course. It could be BSc Physics or Mathematics or Chemistry or Biology or whatever interests you. Then if your aptitude and passion still stays in science, you go ahead with your master's. And if you really are keen on specializing in astrophysics and space science, do a PhD in astrophysics and try to find an area of astronomy which you really find interested in, plus which you feel comfortable with, so that you'll be able to contribute in a wee bit sense. So it's all about finding your inner calling even in the area of astrophysics, because astrophysics is super specialized these days. You have stellar physics, solar physics, gamma ray astronomy, cosmology, climate change, lots of different branches. My branch, which is the solar system astronomy. So solar system dynamics is about understanding the orbits and trajectories of asteroids, comets, meteor showers, and so on, and how they interact with the Earth. And we need fresh, young brains from our own rural parts of India. Some kids are really fascinated by the night sky, but they don't get the opportunities to pursue such a career. So I welcome a lot of young, bright brains to come to my field, and there are plenty of exciting opportunities there.
Thank you.
That was Dr. Aswin Sekhar from Paris Observatory, sharing the transformative moments that shaped his pursuit of knowledge.
It's not just about the mysteries of the universe. Astrophysics has far-reaching implications here on Earth as well. Tonight, we'll also explore how this fascinating field influences technology, inspires innovation, and encourages us to think beyond our boundaries. Here is Dr. Anand Narayanan, Professor at the Department of Physics, Indian Institute of Space Science and Technology, Trivandrum, with us to tell us about how Adithya L1 mission pursues the enigma of space weather and why such space monitoring is needed.
Like all stars in the universe, the sun is a very dynamic object. There are violent eruptions that happen on the surface of the sun every now and then. They are called solar flares and coronal mass ejections. These flares and ejections are sudden and violent bursts of radiation and high-energy particles. Such events, when they occur, can last for hours to days. And when these high-energy radiation and particles reach the Earth, they can produce a geomagnetic storm that can disturb the upper layers of the Earth's atmosphere by heating them up. The charged particles in such storms can disrupt communication networks of satellites. They can affect the precision of GPS systems and can temporarily disrupt electrical power grids, causing total blackouts. It becomes therefore very important to monitor the sun constantly, study its short-term and long-term behavior if we want to understand how the conditions in space right outside of Earth is likely to get affected by solar activity. There is also the equally important aspect that because of being very close to us, there is no other star in the entire universe that we can study in such detail like the sun. There are telescopes on Earth that are designed to study the sun, but the sun emits energetic radiation like the X-rays and ultraviolet, which we cannot detect from ground, due to the upper layers of the Earth's atmosphere absorbing them. There are also a constant stream of particles that are coming from the sun called the solar wind. These particles are deflected by the Earth's magnetic field and they never reach the ground. Putting a telescope in space would allow us to study the sun continuously in far more detail, especially its more energetic phenomena. This is what the Indian Space Research Organization and the Indian scientific community are planning to do with the Adithya L1 mission that was successfully launched into space from Sriharikota on September 2nd this year. Adithya is India's first space solar observatory and also our first mission to the L1 Lagrange point. Lagrange points are positions in space where if you keep a smaller object like a satellite, the gravitational forces from the sun and the earth acting on that object gets exactly balanced by the centrifugal force due to its orbit around the sun. In simple terms, it's a force equilibrium point. And what that means is that a small object like a satellite or a space observatory kept at that point would remain more or less stable at that point throughout its time. For the Earth-Sun system, there are 5 Lagrange points. Of these 5, only one is between the Earth and the Sun. That point is called the L1 point, and that is where ISRO's Adithya mission is going to be positioned. The L1 Lagrange point is at a distance of 1.5 million kilometers from Earth towards the Sun. But even at that distance, Adithya would be only 1% closer to the Sun than Earth. The Adithya L1 mission carries with it 7 scientific payloads. The Visible Emission Line Coronagraph, will study the outer million Kelvin plasma atmosphere of the Sun called the solar corona, especially the large ejections of magnetic field and plasma from the corona. The Solar Ultraviolet Imaging Telescope, also called SUIT, will take pictures of the outer layers of the Sun at near ultraviolet wavelengths using different filters. The images obtained using each filter will show a slightly different layer of the Sun. Such data would help scientists understand how energy flows from one layer to another within the Sun. The Solar Low Energy X-ray Spectrometer and the High Energy L1 Orbiting X-ray Spectrometer are two other payloads on Adithya to study the X-ray flares from the Sun over a wide X-ray energy ranges. The Adithya Solar Wind Particle Experiment and the Plasma Analyzer Package for Adithya payloads will study the energetic protons, alpha particles, and other ion compositions of the solar wind. The Advanced Triaxial High-Resolution Magnetometer payload is capable of measuring the low-intensity interplanetary magnetic field strength at the L1 point along the three spatial directions. This combined suite of 7 payloads will provide crucial information that will help scientists understand some of the long-standing questions related to the corona of the Sun, the frequent flaring activities of the Sun, and the dynamics of space weather. The payloads are all indigenously developed by the Indian Institute of Astrophysics in Bengaluru, the Inter-University Centre for Astronomy and Astrophysics in Pune, the Physical Research Laboratory in Ahmedabad, the Space Physics Laboratory of the Vikram Sarabhai Space Centre in Thiruvananthapuram, the U.R. Rao Satellite Centre in Bengaluru, and the Laboratory for Electro-Optic Systems, which is a division of ISRO in Bengaluru. Adithya L1 was launched using the PSLV-XL launch vehicle from the Satish Dhawan Space Centre in Sriharikota. The payload had a liftoff mass of about 1,481 kilograms. PSLV-XL has placed the spacecraft in a highly elliptical orbit around the Earth. The propulsion system on Adithya is being used now for subsequent orbit racing maneuvers, eventually sending it on its path towards the L1 Lagrange point at a distance of 1.5 million kilometers from the Earth. The entire journey is expected to last for 125 days. Once it reaches L1, Adithya will enter into an orbit around the L1 point, where it will remain for its mission lifetime of 5 years and possibly more. Communication and data transmission with Earth will primarily happen through ISRO's Telemetry Tracking and Command Network, the Indian Deep Space Network, and the Indian Space Science Data Center. From the halo orbit around L1, Adithya will circle the Sun along with the Earth, completing one full orbit around the Sun in 1 year. With the successful launch of Adithya, the Indian Space Research Organization is on its way to becoming the world's 4th space agency after the US, European, and Chinese space agencies to put a spacecraft in the L1 Lagrange point to study the Sun.
That was Dr. Anand Narayanan from IIST sharing with us the journey behind Adithya L1 mission. That was indeed thought-provoking.
Switching gears, let's delve into the realm of medical breakthroughs. The fight against cancer has been a defining challenge of our time. And today, we stand on the brink of a groundbreaking discovery. With the tireless efforts of 2 brilliant researchers, we have reached a pivotal moment where hope is no longer just a distant glimmer but a tangible reality. Welcome to this extraordinary event where science and innovation collide, bringing hope and excitement for a cancer-free world. Tonight, we present to you the findings of this novel invention of nanoparticles to arrest the human lung carcinoma cells that could revolutionize cancer prevention. We have with us Dr. Joan Jacob, Assistant Professor at the Department of Physics, Amulya S College, Trivandrum, and Mr. Jyothish B, Assistant Professor at the Department of Physics, Sri Narayana College, Varkala, to share the details of their research.
Using nanotechnology in medical diagnosis and treatment is taking the healthcare sector to higher altitudes.
In nanomedicine, scientists seek nanomaterials with much better curing effects than conventional medicines. The new nanomaterials can sometimes be mixed with the existing drug to create better results.
We could select only those materials which are non-toxic as well as biocompatible. It will not cause any side effects or should have minimum and bearable side effects. Ferrites are such materials. We know that iron is naturally existing and a non-toxic substance. Its oxides are also abundant. Nearly 90% of lung cancer is from direct or indirect use of tobacco or related products. Worldwide cancer research has brought many types of cancers to curable levels, but still lung cancer is a big challenge. In this scenario, we investigated the anti-cancer activity of various nano-sized ferrites, especially against lung cancer. We have experimentally determined the anti-cancer activities of different ferrites and surprisingly got a very outstanding result for a particular combination. In our research lab, we were preparing ferrite samples through chemical methods. Each ferrite sample was prepared by precipitation of the appropriate raw materials. The samples were well purified and were given precise thermal treatment before finalizing the product. We all know nanomaterials have unique properties because of their crystalline size at the nanometer level. We have conducted various investigations to determine our samples' size, morphology, and purity. They include X-ray diffraction and electron micrographs. We have given more importance in investigating the anti-cancer activity of these non-toxic ferrites.
Our research found that silver-doped zinc ferrite nanoparticles work effectively against human lung cancer. It controls the spread of cancer cells. Cancer cells have an abnormal property that they grow and divide at a rapid rate. Our body has a natural mechanism of destroying unwanted cells, and this mechanism is called apoptosis. Genetic engineering has identified that a human gene named P53 has a high potency to induce cell death. Cancer researchers are going in a direction to seek methods to stimulate the gene P53, hence controlling the cancer cell spread. Several researchers got good results by using metallic nanoparticles in cancer treatment.
In our study, we conducted the anti-cancer activity of silver-doped zinc ferrite nanoparticles, specifically on lung cancer tissues. We could observe that our silver-doped zinc ferrite nanoparticles could produce apoptosis by causing the breaking of the cell membrane. Nanoparticles are very small in size, hence they can penetrate through the cell membrane and accumulate within the cells, causing effective destruction of cancer cells. We have estimated the anti-cancer properties of our samples systematically and scientifically. Lethal concentration 50 or LC50 value is a standard measure of the anti-cancer activity of a medicine. It gives the amount of the drug required to kill 50% of cells within a specific period. Large LC50 means that you need a higher concentration of that medicine to cause 50% of cell death. Our studies showed that the LC50 value of our silver-doped zinc ferrite nanoparticles is 7.17 microgram per milliliter on lung cancer cells. This is a trace amount, and it was confirmed that silver-doped zinc ferrite nanoparticles can potentially destroy the lung cancer cells. We have also compared this value with that of the conventional chemotherapy medicine named 5-fluorouracil or 5-FU. This chemotherapy medicine has an LC50 value of 13.73 microgram per milliliter, which is higher than the value of our sample.
When a medicine is administered to a patient, it may kill healthy cells along with the cancer cells. So, we have conducted tests on the destructive effect of our samples on healthy cells. The LC50 value on healthy cells was determined to be 172.9 mg/ml, which is very high in concentration, nearly 25 times higher than that for cancer cells. The result is interesting since we require a deficient amount of the drug for killing lung cancer cells, which does not cause much damage to healthy cells. This is a type of targeted treatment for lung cancer.
The microscopic images showed significant morphological changes in lung cancer cells on treatment with our samples. The cells were detached, shrunken, dispersed, and cytoplasmic shrinkage occurred after treatment with the samples. Our samples can potentially restrict the migration of lung cancer cells and lessen the likelihood of metastasis.
We have conducted several other related investigations to study our samples' effect on lung cancer cells. Some are fluorescence activated cell sorting analysis, migration assay, the sample's impact on the antioxidant systems, indirect ELISA, cell cycle analysis, and finally the mRNA expression of gene P53 and gene P21 by real-time PCR analysis. All these results strengthen our silver-doped zinc-ferrite nanoparticles' ability to fight lung cancer. The next step is to test it on animals and then on humans.
You were listening to Dr. Joan Jacob and Mr. Jyothish P, the architects who unveiled the potential of nanoparticles in combating human lung carcinoma cells.
The world has, over years, witnessed numerous scientific and technological innovations. Artificial intelligence has turned out to be one among the most fascinating and unprecedented discoveries of all time. These intelligent virtual agents are not just lines of code. They are revolutionizing how we interact with the digital world around us. This night, we have with us Amulya S, science writer from Bengaluru, with a talklet on AI chatbots.
In modern times, the advancement in science and technology have opened up numerous new possibilities in our lives. Among such innovations, one can consider chatbots as a prominent discovery of this era. Its unique features and straightforward usage appeal to people of all ages, making it a universal favorite. Just like human conversations, chatbots come in various forms. They could be in the form of Q&A, simple conversational interactions, or tailored to suit the user's convenience. Moreover, the interaction with these chatbots is not limited to a predefined path. Instead, they adapt to our questions, remember our preferences, and create an engaging experience for us. When we ask a question, it does not restrict us to a single answer. It takes into account our choices, selections, and previous interactions to provide relevant responses, keeping in mind our past behavior. These chatbots have become our companions like trusted friends. However, their place cannot replace the bond of true friendships, as they remain mere inventions of our ever-progressing world. Moreover, simple chatbots aid us in our day-to-day tasks, acting as virtual assistants in our lives. Whether it's making a to-do list for the day, reminding us of grocery items from the nearby store, or suggesting the best restaurant around, they proficiently manage these activities. They have evolved to the extent that the term smart chatbot now implies logically interpreting our queries and suggesting artistic methods to support our enterprise and business ventures. Progress in this domain continues every day, and today, the ultimate chatbot would effortlessly provide us with logical and creative solutions, contributing significantly to our growth. In conclusion, chatbots have indeed become a fascinating discovery of this age, supporting our development and facilitating interactions like an understanding friend. However, let us remember that their responsibility is limited and cannot replace genuine connections that make life rich and fulfilling. As we embrace and appreciate this technical marvel, let us not forget our responsibility to cherish and preserve the essence of human relationships.
Science is not confined to laboratories and research institutions. It is a source of inspiration, sparking curiosity and wonder in people of all ages, encouraging young minds to dream big, reach for the stars, and perhaps one day become the innovators who shape our future. Thank you for tuning into Radioscope. Stay curious, keep exploring, and remember, science is a never-ending adventure. Join us next time for more wonders and revelations on Radioscope. Take care, and may the spirit of science guide you on your own path of discovery. You were listening to Radioscope, the National Science Magazine. This program was produced at the studios of Akashvani Trivandrum by MS Asha. Narrated by Anakhasree and
Anakha Jyothish.